We can represent the situation that you've just seen by this picture. We have a pulley. Now we assume the pulley is light and low friction. The pulley that you just saw is pretty low friction. The two dimes that were able to accelerate this system, which had a mass of 100 grams plus the mass of the dimes, had a mass of only, or a weight of only about 5%, or a mass of only about 5% the mass of the system. And that means that our friction was less than 5%, which is pretty good. Now friction in this pulley tends to run between 4 and 5%. In any case, we have a light, low friction pulley here. If we have two weights, and let's say that as we did on the machine that we saw in the video, if we put the two dimes on this side will have more weight than this side, indicated by a bigger mass here than here, bigger red area on this side than this side. So we have weight W2 here and a weight W1 here. In the case you just saw, the weight W2 was the 50-gram weight hanger plus the two dimes, about 55 grams maybe. The weight on this side was just 50 grams. I'm sorry, the mass on this side was 55 grams, the mass on this side was 50 grams. The weight, of course, is what we get when we multiply the mass by the acceleration of gravity. And the weight will be measured in newtons. In this case, 0.055 grams times 9.8 meters per second squared, or a little over half a newton, and over on this side about half a newton, maybe a little less than half a newton. In any case, the system that we're going to talk about consists of the weights and the string. It doesn't consist of the pulley, but we're neglecting the pulley. We could include the pulley in the system if we want. We're going to say that its weight and its mass and the difficulty of accelerating it are all negligible. But let's just pretend the pulley is totally out of the picture, and we just have this red system consisting of the mass and the string. And of course the string has very little mass. The positive direction will be this way, where this weight descends and this weight ascends. Again, that corresponds to counterclockwise rotation of the pulley. There's a little bit of frictional force in the pulley, as I just indicated, maybe about 5% the weight of the system effectively. So that if we analyze the forces in the system, we see that the total force in the system is negative W1, corresponding to the weight 1, which is in the opposite direction to the motion, the positive direction being this way, up on this side, down on this side. So we say that weight is a negative force. So we have negative weight 1 minus the force of friction, because the force of friction always opposes motion, plus the weight 2. Now again, the force of friction opposes motion. That motion is going to tend to be in this direction, the direction of the greater weight, and in this case will be backward to the positive direction or in the negative direction. So this is our net force on the system. Now what's the mass of the system? Well, it's just M1 plus M2. M1 being the 50-gram hanger in this case, M2 the 50 grams plus the two dimes, are about 55 grams. So the acceleration of the system is going to be negative W1 minus F plus W2 over the total mass M1 plus M2. The total net force divided by the total mass.